Okay, by popular demand, I am going to do number 7 on 4.6 CW. Alright, a box weighing 325 newtons moves with a constant velocity across the floor when it is pushed with a force of 425 newtons, exerted downward at an angle of 32.5 degrees below the horizontal. Find the coefficient of kinetic friction between the box and the floor. So it gives you a little diagram to kind of show you how that force is acting on the object. So here are our givens. It says it weighs 325 newtons, so our Fg here is automatically 325. We don't have to figure out Fg since it says it weighs that much. That is what the force of gravity is. Alright, so free body diagram. First step we do every time. Fg is acting down, Fn acting up, and we know there's a frictional force acting against it, and our applied force here is up here. So this is our Fa. Alright, the angle that we're talking about sorry, is below the horizontal. So the angle measured here is right in between here. So this is our theta. And so our component triangle looks like this. This is our FAX and this is our FAY. Alright, so that's our free body diagram. You can draw this coming from the center of mass. I like kind of putting it up here to kind of show how it's being applied. Okay, so our net force in the x, we're setting up our net force equations. In the x direction, the only forces we have are FAX and F of F. Alright, so in the x direction, our FAX minus F of F, and it equals 0 because we know we're at a constant velocity. We don't have an acceleration here. So we can set this equal to 0. Our net force in the y is Fn in the positive. Fay is in the y direction as well, but it's negative. It's being pushed down into the ground. So Fay. And then minus Fg. We're sitting on the ground, so both of these equal 0. Alright, so we want to find the coefficient of kinetic friction. We know one equation that deals with that. So our frictional force equals mu k Fn. So to solve for this variable here, we have to know our frictional force and we have to know our normal force. In this case here, we can solve this equation for F of F. We can solve this equation for F sub n. So here we get F of F equals FAX, which from our triangle that we have here is cosine. So Fa cosine of the angle. So F of F equals 425 I screwed that up. 425 newtons cosine of 32.5 degrees. So that's our trig function here for FAX. We're using the adjacent side, you're using cosine. So F of F in this case is 358.4 newtons. Double checking my calculation. Yeah, okay. And so now we have this one. Now we need to find F sub n. I'll move down here. So F sub n, we're just solving this equation for Fn. is FG plus FAY. So that's FG plus FA. We're using sine now because it's the opposite side. Sine of the angle. So Fn, plug in the values. FG 325 plus 425 newtons. Alright, so we have a value of that one. 553.4 newtons. So now we have this piece of information and this piece of information. We can solve this equation here. So plug in for mu sub k, 358.4 newtons divided by I almost put Fn, 553.4 newtons. So our mu sub k is 0.65. And that is our answer.